Hey guys, in this video we're going to be looking at anonymous inner classes. Alright, so let's get started. I'm going to create a class called Animate Activity Manager. And what this class is going to do is it's going to have a method called accept. It's going to have a method called accept. And it's going to take in objects that implement the activity client interface. Item. This accept method, all it's going to do is it's going to do item.doSomething. So it's just going to call item.doSomething. Pretty straightforward. Now let's comment these guys out. And what I'm going to do is let's now just do, what is it called? It's called Animate Activity Manager. Manager is equal to new animate activity manager. And now let's do manager.accept, and let's just put in our rock. Okay, so if we put in our rock, what's going to happen? We go into our rock class, and our do something method says I can't do anything on my own, I'm a rock. Let's run, and let me comment out everything else actually. Comment this out, that out, and this out. And now we run, and okay, so we just get this desired line of output. Good. Now, suppose that we didn't want to go through the trouble of implementing this or creating a new class, then implementing this interface, and then defining all of these methods, and then providing the method implementations. Well, if we didn't want to do that, we could do this. We could use something called anonymous inner classes. So what these let you do is they let you do this. Where is it? They're putting in activity clients. Okay, so the syntax looks pretty strange when you first see it, so let me explain what's going on here. Up here, we have an example of an anonymous inner class. What we're doing is, we're not actually allowed to create an instance of an animal because it's an abstract class. And if we want to create an instance of an animal, we first have to subclass animal, and then with that subclass, we have to override, or we have to provide definitions or implementations for every abstract method. Once we do so, we're actually able to instantiate the subclass. We're able to instantiate the animal because we're kind of doing some hacks. We're in essence subclassing animal in this piece of code, in this code snippet, by just using, I guess, this kind of syntax. We're subclassing animal automatically, and we're overriding the method. You can think about it the same way. This is the same thing as doing this. Activity client is equal to new activity client. You're not actually allowed to create like an object. This seems like you're creating an activity client object, but it's not quite that. What you're doing is you're in essence creating something that overrides this new activity client interface. So actually, more specifically, what it's doing is it's forcing us to provide the implementation for a subclass of this activity client interface, or something that implements the activity client interface. So in here we can just do, this is an anony class. And then we can just pass in this anonymous inner class that we've defined here, and now we get that. You can also think about this as maybe like this. Class, custom class. So we can define classes, it turns out, in methods too. And we can just do implement activity client. If we do that, now we have to add our unimplemented methods. And then we can do .println. This is intended to and now we can just pass in an instance of the custom class into here. So there's there is a very clear, or there's a relationship between these two. That's so the relationship between these two is these two are basically doing the same thing. And what you're doing here is you're defining a class or a custom class that implements the activity client class. So what that actually means is now you're going to be able to create objects of this custom class. For example, this car class. It does the same thing. It implements this activity client class, and now we're able to create car objects by doing this. So that's what we're in essence doing here. However, because we're implementing the activity client interface, we need to provide a definition for the do something method, which we do here. We just do system.out.println. This is intended to blah blah blah. So we're overriding this activity client method called do something. But this is exactly the same as basically creating a class, like up here, and then implementing activity client. That stuff is just being hidden from us when we use this kind of syntax. And so we can either do this kind of format where we create a class, implement the interface, and then pass in an instance of the class, or we can just pass in the anonymous inner class we've declared over here, where the class is kind of being generated for us. Now this is useful in an anonymous inner class because it functions like a normal class. We can store our own variables inside of here, myval. So we can store variables inside of our anonymous inner class, and then we can do all kinds of stuff. We can do myval++, anything that we would need to do. Generally, anonymous inner classes are useful because they make your code cleaner. They make it shorter because now you don't have to declare all of these other classes. You can just pass it in very, very easily through. You can just pass it in, like for example, we're passing it into a method here. We're passing this anonymous inner class into this accept method, and it's very simple. We can just do this is inner class being provided method, and we run, and we get that. All right. So this was an overview of anonymous inner classes. In the next video, we're going to look at lambda expressions, which make it even easier to use them. I'll see you guys then.